Good afternoon, everyone. All right, that sounds good here. All right. It's indeed my pleasure here to introduce our keynote speaker. So first, I'm Imad Al-Qari. I'm a professor of civil engineering, and I'm directing the Illinois Center for Transportation. And I had the pleasure to meet Bobby more than a year ago, almost 2 years ago. And he let me drive an autonomous vehicle that time, so that was exciting for me. So Bobby is the founder and CEO of AutonomouStuff. It's a leader in the automotive and technology industry. He founded this company in 2009 to serve the growing interest in the automated vehicles in various markets, including automotive, mining, military, agriculture, aerospace, and academia. He's one of the first to develop and bring to the market an automated research and development vehicle. As a single founder, Bobby has developed a company like no other in the automotive industry, triple-digit growth for the last 3 years. He works with local robotics teams and universities to inspire the future leaders to build safer and better world. Prior to founding the AutonomouStuff, Bobby led technical sales at Springfield Electric. He holds a bachelor's degree in business administration management. I definitely would like to welcome Bobby here, but I can tell you one thing on the side that it's really impressed me is in our lab, many times the students, they come to do testing, and he has some people from his company accompany our students just to test this new technology to develop as part of their research project. So his commitment to the research and development and working with the university, it's truly special. So Bobby, it's my pleasure to welcome you.
All right, thank you for that kind introduction. I'm not sure who wrote the introduction, but it was beautiful. So hello, everyone. So I'm Bobby. I'm the CEO and founder of AutonomouStuff. I am a native to Central Illinois, so I was born and raised in East Peoria. And my company is headquartered in Morton, Illinois, right here in the middle of Illinois, in the middle of a cornfield. If you don't know Morton, we are also the pumpkin capital of the world. So that if that doesn't recruit engineers to our city, I'm not sure what does. A couple of weeks ago, I was in Japan presenting, and there were 700 people in the audience, and everyone was wearing a white-colored shirt and black pants. So it's really nice to see a little bit of color out in the audience today, and also some younger people, which is great. So again, thank you for the introduction. Thank you for organizing this. I'm happy to be here. Like Ahmad said, I'm very supportive of the local economy. I'm very proud of the Midwest and our culture here. And I want to do more with the University of Illinois as much as we can. So in fact, I think we're shipping one of our research vehicles from California here to one of the labs that can be shared for the students and professors for different projects. So I'm looking forward to spending more time here if I can. A little bit about my background. So I started providing technologies to enable autonomous driving in the mid-2000s or so. So if you're familiar with the industry, the DARPA Urban Challenges and Grand Challenges were in 2004, 2005, and 2007. So I started selling sensors to help enable them to build robotics since then, and ever since then, and I still do that today. So I self-proclaim that I've sold or provided more technologies to enable autonomous driving research than anyone else in the world has. And we'll talk a little bit more about what I'm doing after I get through the history of autonomous driving, but we have something like around 3,000 customers worldwide. So there's a lot of activity happening in automated driving. If you're not in the business, you might not understand that there are more players than just Google and Uber or Waymo involved with automated driving. So when I started walking up here, I started thinking about what you guys were expecting me to say when I was up here. So I'm going to cover some of those things. But I also thought, I bet at least half of you guys were thinking, there's no way in hell that I would let my child ride in an automated driving car by themselves to take them to school or to take them to church or whatever. And it's not my job to tell you guys that you're wrong, but I think that you're wrong. And so humans adapt technology faster than we think we do. So I have a couple of slides here on a couple of proof points to show you the history of how we adopt technology. And it's going to be no different than with automated driving than it has been with technologies in the past. Yeah, so I guess I'll get going here. So a little bit of history to set the stage. At the turn of the century, the streets were filled with horses and buggies, and humans treasured these animals. And these, at this time, the horse and buggy did everything for a human, right? You use it for transportation, you use it to plow your fields, you used it as a companion. And if you were to ask humans at this time, at the turn of the century, if you were to ask them if they would get rid of their horses in the next few years and replace them with some type of mechanical device, they would have said no way in hell, just like we say today that we're not going to allow our children to get in an automated driving car by themselves. And that wasn't that long ago. Even though horses introduced a lot of public safety concerns, as you can imagine, a spooked horse collided with trolley cars, it trampled pedestrians, they crashed into store windows, and they were health hazards as well. I mean, there were several thousands of pounds of manure all over the streets, and this was a significant issue that at the time the government was trying to figure out how to handle. But nobody thought that they were going to be overtaking themselves with mechanical devices in just a few years. So if you take a look at this slide, at the beginning of 2008, there were fewer than 200,000 vehicles on the road. That's also the same time that the Model T was created. But it wasn't until 1913 when the production line started, and then in 1924, 10 million Model Ts roll off of the assembly line. But if you take a look at these two pictures, at the turn of the century, the streets were full of horses and buggies. In 1917, there was a traffic jam on those same streets. But that was just 4 or 5 years after production started that this happened. So we go from 200,000 vehicles worldwide to traffic jams in some of our urban cities in just a few years. So again, we adopt technology extremely fast. And I think about the Model T a lot like the way that I think about operating systems today. So if you think about Android and iOS, and the Model T was very similar. So it had a common platform that you built on top of that allowed you to build a variety of different types of products on the same platform. And the Model T was basically like that. It was a modern day, or it's like the modern day Android or iOS. So, and today, what's happening in the automated driving industry is a lot like that. There are open platforms used for automated driving. They have open sourced the entire stack of software needed to drive autonomously, both on the highway and in the cities. So what's happening is the barrier of entry is significantly reduced. So what has been researched for the last 3 or 4 decades is now available to download on GitHub. And that's going to make a significant shift very, very quickly in transportation as we know it today. So the next slide is a little bit closer to something that we can relate to. This has happened, and I think all of our lives for everyone that's in the room today. And what this graph shows from 2007 to 2020 is the adoption rate of smartphone technology. So the BlackBerry was introduced in 2005, which doesn't even show up on this chart. And granted, I know that there were other cellular devices invented before 2005. But if you look, the iPhone wasn't invented until the very beginning of this chart, which is 2007, but the adoption curve didn't start rising until 2010 when Android was introduced. So Android was the first open operating system that allowed lots of different type of hardware providers to build on top of a common platform, similar to the Model T analogy that I had talked about. So between 2010 in 2015, you go from 15% adoption to the majority adoption of humans throughout the world utilizing smartphone technology. And that's quite amazing. And again, that's only just 4 or 5 years that it took humans to adopt something that didn't exist before, essentially, to everyone in the world having one in their pocket. And I'm quite sure that in the mid-2000s, and I'm old enough to remember this, I'm 37, and I remember when I got my first phone in my car when I was 16 and I had like 100 minutes to use, my parents were like, there's no way in hell that I want to carry my phone with me while I'm driving, because that's why I leave my house, is to get away from my phone. And it's hard to remember those times now because we use these things every single day. Even when we're going to the bathroom, we have the phone in our hand. And it's kind of ridiculous, but it's the truth. But just a few years ago, we thought that this was impossible. And so again, within a couple of years, this has changed the way humans operate in the world, and it has changed our complete lives as we know it. And again, in only 5 short years. So this slide, this is basically a slide that shows the progression since I've been in the business of what's happening at a very high level, also what the prediction of mass production or adoption of autonomous driving at some level throughout the course of the years. So the first bubble here, the orange one, is 2004. So that's kind of like the birthplace of automated driving, when the government funded these projects called the DARPA challenges. It was a military effort, and the first 2 challenges in 2004 and 2005 were in the desert. It was a 150-mile course, and a few universities and a few industry players got involved. Carnegie Mellon, of course, was one of the leaders, and Stanford, and a few others. That was kind of the birthplace, and at that time, no one was really thinking about automated driving being useful for commercialization. It was really for military applications, military convoying. Maybe there was a few guys out there that had a dream of automated driving, like in the Jetsons or something. But basically, the adoption was like, oh, maybe never, because the technology was so far behind. The computer racks, I have an Urban Challenge car at our office, and the entire back of the SUV is full of computing. And now it's like we're using computing about this big that used to fill the entire back of the SUV, and that was just in 2007. If we fast forward a little bit, in 2009, Google started XLab, which was Sebastian Thrun. It's also the same time that they released the Chrome operating system and Android 2.0. And NVIDIA sparked the big bang of artificial intelligence. So that's when AI started coming alive, is in 2009. So high-performance computing was now something that was more commercialized, allowing massively parallelized processing. It's also the same year that Google announced the Google Brain on the NVIDIA hardware. And since then, artificial intelligence hasn't been the same. And at that time, when Google started driving their golf carts around in public, the industry was like, well, I think maybe this could be possible, and it was more like 2050 timeframe. Some people were saying 2030, but most of the industry was saying, well, maybe we'll see commercialization in 2050. So when I started in 2010, that's when the incredible AutonomouStuff was founded. That's the company I founded. It was still just the beginning. And that's also when the automakers started waking up. It was 2010. So when I founded the company, and my whole idea of the concept of the foundation of the company was that I wanted to enable the future of automated driving. And I wanted to help jumpstart customers or universities or whatever the industry is, jumpstart them towards automated driving. So when the automakers also woke up, it's because they were afraid of what Google was doing and these data guys were doing, and they could finally see that this could be very disruptive to their industry. And that was happening in 2010 timeframe. There were a few earlier adopters, but for the most part, it was basically 2010. It was also the same time that VizLab did an intercontinental autonomous challenge, and they drove 9,000 miles, 9,900 miles from Italy to Shanghai, and they did that mostly autonomously. And until then, most of the autonomous driving stuff was not as public as it was until it was in 2010. And then shortly after that, Nevada passed a law in 2011 because of what Google was lobbying to do so they could legally drive autonomously on the streets. That happened in Nevada. And then 2012, shortly after Nevada, Florida announced that as the second state in the United States to allow testing of autonomous driving. And then Nissan announced that they were going to do autonomous driving and start deploying them in the 2020s. So as you can see, again, in just a couple of years, how the timeline shrank significantly. So then it was 2035 in 2010. Moving forward to 2016, this is when everything exploded in automated driving. So a small startup started up by Kyle, who I got to know quite well and who I sat down with him prior to him starting his company, and I sold him radars and cameras and stuff like that. GM acquired Cruise for about $1 billion. And they were a startup of about 40 people or so, and they had just been operating for about a year, actually much less than a year. So that woke up the entire industry. And the entire industry realized that, for one, there's a lot of capital available for automated driving technology, so that spun, there was a huge startup uptick because of that. All the VCs in Silicon Valley and other places in the world decided that, hey, we're going to start spending some money on automated driving. So that enabled lots and lots of startups to sprout up everywhere, and billions of dollars were dumped into this economy. And now there are many hundreds of startups working on automated driving technology as a result of that. That was also the same time that Delphi, which is a very traditional automotive tier 1 supplier to the automotive tool chain, prior to this time, they only made they just made hardware. They weren't really a software company. I sat down with the executives of Delphi at some point and said, you guys are going to turn into a software company sometime in the near future, and they thought I was crazy. And then I introduced them to a startup company spin out of CMU that they acquired shortly after that, and that was Automatica. So Automatica was spun out of CMU. Delphi acquired them, and now Delphi has spun out a company called Aptiv, which is a automated driving entity. So they have reinvented their entire business model because of automated driving, and this is happening all over the world. Going back to Cruise, I forgot to say this, SoftBank announced that they're investing another $4 billion into Cruise. Honda just announced they're investing another $2 billion into Cruise, and there's more and more of that going on all throughout the entire industry. So moving forward, at that time now, 2016, the deployment prediction was 2025. So and then we look at today, predicting, and some people are predicting at the end of next year in 2019. So Cruise is saying that they're going to have some deployment in 2019. Waymo is saying 2019. These are going to be very small fleets of vehicles, relatively speaking, compared to the size of the automotive industry. But very shortly after that, that's going to scale out to every major city throughout the world. So Google has bought 62,000 Pacificas, 20,000 Jaguar I-Pace cars. Again, that's only, let's say, 100,000 vehicles, but it's really just the beginning, and I'll circle back around to that at the end of this presentation. But now they have billions of miles of simulation under the belt, and I think that they're doing something like 9 million miles a day of simulation or something like this. So everyone is in the business now. There are thousands of test vehicles throughout the world. There's a tremendous amount of data that's being collected and used for artificial intelligence for automated driving. And my own company, AutonomouStuff, is building between 60 and sometimes up to 100 of these automated driving research vehicles a month, and supplying them all over the world for research. And I expect to see some deployment happening very soon, in fact, in just a few months. So what else is driving this? Again, I'll touch on this massive investments. Whenever there's money, there's an industry, And there is a tremendous amount of money right now being thrown into automated driving. Every major university now has a program or is developing a program for automated driving, including the University of Illinois, but there are many others. I'm very lucky that I get to support most of them all over the world. But again, if you just take a look at this list, there's just a massive amount of investment. I mean, when Intel announced buying Mobileye for $15 billion, that is a massive shift in the industry. The silicon manufacturers, every single one of them, it has a huge initiative, again, spending their own billions of dollars of their own R&D into that. That includes NVIDIA, Intel, Renesas, NXP, TI, all the silicon guys are pushing towards automated driving and spending tons of money. All the automotive OEMs have now realized that automated driving completely changes their business model in the future. So the days of us having 5 cars in our garage or on our driveway, or at least a couple, those days are gone. It will be about just calling the Uber app, and the service probably will be free. Why do we need to own all these cars when we can just drive them or ride around in them for free, except for when we just want to have fun with the cars, just like people today still have horses because they love horses. So this is a significant shift that's happening in the entire industry, and the automakers and the tier 1 suppliers they're scared of what their future business is going to look like. So there's a massive amount of consolidation happening in the industry, and a huge shift of business model plans for how these guys are going to do business in the future. And this is why you see guys like Toyota and GM investing into Uber and Lyft, and Didi is the other one. It's the Chinese version. And it's not just these $500 million each. They're really spending billions of dollars with each other and collaborating efforts. So it's quite amazing. But this investment reduces a significant amount of time and money that it takes to develop this technology. So this is a slide that I think that I'm supposed to talk about. So I think that most people say this is why automated driving is happening, is because it's going to save a lot of lives and it's going to save a lot of money. And you know, the crash economy is such a big thing, and everyone has a story to tell about a relative or someone in their family who has been in an accident. And yeah, it's really interesting that how distracted we are in driving. I mean, it's hard for me to even get on the road without my phone in my hand, and I don't think anyone now drives without their phone in their hand. So driving is the distraction, of course. But if you were to equate the number of crashes per day, so if you were to think about a 737 that can hold 215 passengers, this is equivalent to 15 737 crashes every single day. So it is a serious problem. It is what I'm supposed to talk about, and it's an epidemic that needs to be fixed. And that's what automated driving is supposed to be about. But what it's really about is the data. So there's more data created every single 2 days now than there was in the previous history of mankind. Something like that. So this is what it's really about. This is why Google and Uber and Lyft and everyone is investing these billions of dollars, because they want access to all the data that an automated driving car can collect, because it's basically the next smartphone on wheels that we will be spending a lot of time in. So they want to make sure they get access to that data. The Eiffel Tower picture is here. I don't know if that's my phone over there. It might be my phone. Sorry about that. So the Eiffel Tower is here to represent how much data actually is created. So if you were, in a single day, we would fill 10 million Blu-ray discs worth of data, and if you were to stack those on top of each other, that is the height of 4 Eiffel Towers stacked on top of each other. That's how much data we're creating every single day, and that's what automated driving is really about, is capturing that data, capturing our attention, and then somehow monetizing it monetizing the business models. So data is the new oil, as a lot of people say. So what happens when there's a complete disruption in an industry that's, probably the largest industry that exists? there's a lot of consolidation happening. So there are tons of acquisitions. Every single day there's an acquisition announcement. In fact, I just was acquired by a company, a publicly traded company called Hexagon. So I'm a part of this consolidation as well. But we're also consolidating. It's consolidation happening unlike any time other before. GM and Honda just announced collaborating and sharing data for self-driving. In fact, they're collaborating and building a purpose-made self-driving car that I don't know if they're co-branded or what's going to happen there, but these are things that would not happen in previous years. Ford, Uber, and Lyft announced an agreement to share data. Again, the data is where the value is. So when these industries start to share this data, you know that it's a significant issue that they're trying to solve, and it must cost many billions of dollars. So they're trying to pool up their resources and share that data together. And they also all own each other, so there's that as well. So it doesn't make sense for all of them to be spending their money independently. And then you have guys like Baidu. If you're not familiar with Baidu, they are the Chinese Google. So everything that Google does, Baidu does it in about a month later. And so they definitely are the Google of China. And they have now released a massive self-driving data set named Apolloscape. And that's about 10 times larger than any other data set that's available out there now. So what they have done, which I do have a couple slides on later, is they have created an open operating system for autonomous driving, much like Android is. And in fact, they're calling themselves the Android of autonomous driving, and that's called Apollo. And I'll talk about that here in a little bit. But again, this saves researchers massive amounts of time and money, and therefore reducing the barrier of entry and increasing the adoption of technology. There are several other collaborations that are happening that I have in my notes here. Volvo has Zenuity. It's a spin-out to create technology quickly. Ford has Argo, also a spin-out that they invested $1 billion into that works almost exclusively for Ford. GM has Cruise. So all the major automakers have these little spin-outs that help them move faster with developing this technology. Again, moving the whole industry forward much faster. And what this really comes down to is that we were smack in the middle or the beginning of the fourth industrial revolution. And I place this slide here because this industry is experiencing the results of this revolution, and this fourth industrial revolution is fundamentally very different than the previous three. Innovations in AI, biotechnology, autonomous vehicles, other emerging medical technologies. I mean, this is a very, very highly disruptive time in history. There's not a business in the world that's not about to get disrupted because of where we are with technology, the pace of innovation that's happening. There's no one that is safe right now. When people ask me what my 5-year plan is, I just have to kind of laugh because who knows what the hell the next 5 years is going to look like. Look what's happened in the last 5 years. What's most important is that we maintain agility and we move very, very quickly. And that's why big industry like the automotive guys are in trouble and why they're spinning off companies to try to move much faster than they have in the past. But we're very accustomed to this technology advancing rapidly. It's very natural for the human to do this. But for about 99% of the human history, it didn't. And this has all happened in the last 0.1% of our existence, which is kind of mind-boggling to think about. There are several books out there about the fourth industrial revolution that I would recommend that all of you read because it really does put your mindset into a different place on how fast things are about to change. Okay, switching gears a little bit, I also think that autonomous stuff has had a lot to do with why automated driving is moving faster. So my mission when I founded the company was to enable the future of transportation by making it easier to build automated driving research platforms. And we have done that, and we have provided more of these than any other company in the world. And this is kind of the evolution of our company, and it's kind of like the evolution of the entire industry as well, because when I started the company, I've grown it to where it is today, and we have completely bootstrapped it from day one, so we haven't taken in any investment into the company until now. So I grew the company by adding value and providing technology to automated driving as the industry was growing. So we represent basically how the industry has evolved. So we provide all the individual components that enable autonomous driving, the integration and software services to help jumpstart our customers. We pull all that together, and we actually build automated driving research cars that every major industry player in the world is using. And then this is like the smartphone on wheels that they get, that has all the sensors on it, like the GPS and the cameras and the laser scanners and the radars. And our customers are building the applications that are used for automated driving. And what used to take 10 years to put this together, now we provide them in a week, 1 to 6 weeks. We have significantly reduced the time it takes to start automated driving research. And then the last piece of this is the data intelligence. The beautiful thing about building platforms that create a lot of data is that you need to do something with this data. So these automated driving cars are creating between 8 and 20 terabytes of data a day. And if you were to really think about how much data that is, it's really hard to imagine, but it's a tremendous amount. Once you start putting a fleet of cars out there collecting this type of data that's being used for neural networks and AI, you have a massive stack of USB drives sitting on your desk at the end of the day, and you have to figure out what to do with that. So we developed an entire business unit basically to help customers understand how to handle all this data, how to physically store it, and so forth. And we do this all over the world. So we have entities or partners in every major developing area that cares about autonomous driving currently. And it's not just automotive. When I talk about automated driving coming sooner than you think, it's in every single industry on wheels. So the military has been doing it for a long time. Well, I have a picture of a ship here. It's not just on wheels. It's really anything that moves from place to place. But every single one of these vertical segments is focusing on automated driving. And all of them are using the same technologies. All of them are trying to repurpose the same sensors. And it is about to explode as we speak. Every single day there's a new announcement, a new investment. It's a really good business to be in if you're looking to get into a new career. So moving forward, what I think is also helping reduce the barrier of entry, again, are these platform vehicles. So here's a list of cars that you can buy from us, and there are a few other companies that do this. If you're a researcher or a university or a company and you wanted to do automated driving research, you can literally go onto our website, select the car you want and the technology, and it's like a shopping cart. And at the end of the day, this is kind of what it looks like for a typical automated driving car. It's full of data producing sensors. So you have the high definition cameras. Some of our customers are putting up to 10, 14, 4K cameras all the way around the vehicle. As you can imagine, that it is a tremendous amount of data. But they're also, in addition to those 14 4K cameras, they might add 4, 5, 6, 7 different laser scanners that are all producing about 1 million points of data a second. They're adding GPS systems, differential GPS systems, very high precise fiber optic IMUs, a full set of ultrasonic sensors, 5 or 6 radars. All of this is being integrated into the cars, and all of it's being used for automated driving, and it's all important for automated driving because, of course, you don't want to put your life in the hands of a vehicle driving down the road at 80 miles per hour relying on one type of technology because all of them have failure modes that you want to try to avoid, right? So cameras, if you're relying 100% on cameras for automated driving and it gets foggy or there's mud splashed up on the camera, then of course the functionality of the camera is not going to work, so you need a backup, which would be a radar. So this is what we do. We enable these guys to do automated driving research. And here are a few of the semiconductors players. So NVIDIA, Renesas, QNX, Intel, Qualcomm, Mobileye, the list goes on. And this isn't all of them. All of them are customer of ours. We help jumpstart all of them towards autonomous driving. Because 5 years ago, most of these guys had no idea what they were going to do with automated driving, and most of them didn't know what to do with a laser scanner or a radar or a camera. Most of them knew cameras. So we helped jumpstart them in their research, and now all of them are coming out with platforms specifically designed and manufactured for automated driving. Again, it just happened in a few years, and we're talking less than 5 years that all of these guys have went from ground zero to producing mass production silicon that's optimized specifically for automated driving. Again, this is a massive step forward for the entire industry, and one of the reasons why the industry has moved so slowly for the last 30 years is because this type of technology didn't exist. And now the latest NVIDIA GPU can process 320 trillion operations in a second. And that's going into the trunk of these cars. And it's incredible. There's also a cooling system that's going in the trunk of these cars for that amount of processing, but that's changing very quickly as well. So all of these silicon guys, including these open source guys, are creating an ecosystem of partners around them. And what that means is mass deployment is going to happen in short order. So all of these guys have their own ecosystems, their own software stacks. They're open sourcing all of them to their individual customers. So therefore, none of their customers really have to develop anything themselves. They just need to buy their hardware from these guys. So the guys that are investing billions, if I'm a new player, I really just need to partner with one of these silicon manufacturers, and I could adopt 80% of what I need for automated driving by just buying their hardware. And then on the bottom, these are the open source projects. So you have AutoWare, which is made by Tier 4, that's out of Japan. It's a complete open source automated driving stack. In fact, a lot of our customers use it, and in a few days, maybe in a week, they can drive in simple urban environments by just utilizing open source code. And then there's ROS, which is the open operating system. So it's a robotic operating system. And then, of course, Baidu has Apollo, which I'll show you in a second. So these guys have all created kits. I wouldn't call it plug and play, but it's almost like that. So all of them need laser scanners and radars and GPS systems and technology to plug into their computing platforms. But now all of them have kind of starter kits for automated driving research. And this didn't exist last year or maybe a year and a half ago. So now pretty much you can come to my company, pick one of these kits, and in a few days you have an automated driving research platform running in simple urban environments on various different types of platforms. This capability didn't exist. It would take decades to come up with something like this, and now you can do it in a couple of days. And the list is growing. Again, we have almost 3,000 customers worldwide. I just got to chill on how fast this is growing, and how far we have come from since the mid 2000s when all of this kind of got started. And it's definitely happening in China very, very quickly. In fact, China is our largest growing area, and it's where we will be putting most of our investment into enabling automated driving in China. There's a tremendous amount of capital available. Every single major company is working on automated driving throughout China. Tons of investment. There's a couple of startups on here. Let's see. Roadstar has, I think, $300 and something million of funding. Pony AI has about $400 or $500 million of funding and growing. So there's a huge initiative, and again, everything is moving at the speed of light. Or if you're in China, which I'm very often there, they will say we're moving at China speed. And then there are universities, and we have, I think, University of Illinois is there. So this little buggy on the bottom left will be in one of your labs here in just a couple of weeks. And it's enabled with a bunch of different types of sensors. It's got an open source middleware. And hopefully something amazing will be created out of the university. But you guys are not alone. Every major university is doing this. We provide vehicles, or have provided vehicles for use for research to every major university throughout the world. And all of those universities are also partnered with the industry as well. So they have partnerships with Toyota and GM and Ford everyone else who's spending lots of money on automated driving. And continuing forward, even CES, the Consumer Electronics Show, which 5 years ago was really just plastic stuff for iPhones and the latest TV, the latest headphones, has now turned into an automated driving show. You still have the new TVs and the new headphones, but automated driving is now the sexy thing at the Consumer Electronics Show. So there's a transition happening, and I predict in 2019 it won't be about showing the technology that's used in automated driving. It'll be about showing automated driving applications. So who cares what's making it happen? It's really about the app that affects the consumer that we will be experiencing in the Consumer Electronics Show next year. But for the last couple of years, it's been about research in automated driving and what is the latest and greatest thing. I don't know how many keynotes were last year involving automated driving, but I know of at least 4 or 5 of them that we were involved in with vehicles that we provided, including Intel's keynote. So it's changing very rapidly. This is a common theme. And I'll dive into Apollo a little bit more because I think that it's going to play probably the most significant impact of the adoption of this technology, especially in China. So Baidu is a pioneer in AI technology, and they have used their experience with creating maps, a lot like Google Maps, and their AI technology, a lot like Google's AI technology for search engines. And instead of creating Android or Chrome OS like Google did, they decided to create the Android of automated driving. And they launched that just a year ago, July. So I was on stage in China announcing our partnership because we built all their test vehicles for them. And at that time, there were a couple of thousand people there in the audience, but it was really more like a science project. And I wasn't sure where it was going either, but I knew it was a big deal and I wanted to support it. So at that time, it was basically what was available. So basically, they had the car and they would just drive a loop. They would teach that loop, and the car would just drive around in a loop. And that was all that it was. And it was an open source thing, and it was buggy, and it didn't really work that well. And I didn't buy into it. But their next launch, which was just 6 months later, included perception technology, intersection negotiations, highway driving, simple urban environment driving, and that happened in 6 months. And again, another chill in my skin right now from experiencing this with these guys. So I have a couple of videos to show kind of the progression of what's happening and why I think it's playing such an important impact in the development of this technology.
My name is Josh Whitney. I'm the lead software engineer with AutonomouStuff. So I was very excited to get the opportunity to come to China. So I'm very excited to get to work as part of this team with Baidu. Baidu making an open source project that people can contribute to and add meaning to is very useful.
The relationship between AutonomouStuff and Baidu is going to play a very significant role in the future of transportation.
With the support of the Apollo team, we can finish it in 3 days. We'll be installing 2 platforms. One, the IMU, and then above that, on these 2 rails, we'll install the rest of the equipment. We'll go outside and verify that the hardware is working. It's great to have a wide open space like this for testing. Not hitting any codes. We're going to come up to the end and the vehicle should make a full stop.
In order to enable the future of transportation, you have to put together an ecosystem of partners to bring together the world's best technologies.
The test is going very well. With the help of the software team from Apollo, everything installed and worked the way it was supposed to.
I'm very proud to have developed this relationship with Baidu, and trust me, this is only the beginning. So that was a big, I would say it was more or less a big marketing event. There was a lot of vaporware. There's a lot of vaporware in the industry in general. So I wasn't much of a believer. We don't want to watch it again. So 1.5 happened 6 months later, and then 6 months later after that, 2.0 was launched. And this was at the Consumer Electronics Show this January. And this is when they announced they extended it to urban mobility and simple urban environments. And it was like a great moment for me, because here I am at the Consumer Electronics Show. There's a keynote. The COO of Baidu is on stage. I'm sitting in the front row. Again, I'm just a small-town guy from East Peoria, Illinois. And there's Peoria right there on this big screen as one of the supported cities that they're supporting with Apollo. And so it was one of those moments that, I'm sure I shed a tear, which was awesome, an awesome moment for me. But we played a big role in helping enable that, and now they have really taken off. So they wanted to do another marketing event, so they came to Morton. They said they're going to bring a couple of cameras, so I showed up from a business trip. I got into the office, and there's an entire film crew from Los Angeles sitting in my office. And the office isn't that big, and I don't know, there were 7 or 8 of them. There was a camera guy and a sound guy and a technical guy and a director and 2 other people. I don't even know what they did. So they were going to do a photo shoot and create a video in Morton of us driving around utilizing Apollo 2.0. So the next video is actually taken in our shop in Morton, as well as us driving around the city in Morton. So here is Apollo 2.0. My name is Bobby Hambrick, and I am the CEO and founder of AutonomouStuff. We supply products, engineering services, and state-of-the-art software to help enable autonomous driving. Our headquarters is based in Morton, Illinois, because the Midwestern culture is very hardworking and also very loyal. Baidu is a pioneer in AI technology. They created an initiative called Apollo. It's an open, reliable, and secure software stack for autonomous driving. Now, Apollo is announcing the release of Apollo 2.0.
I'm Josh Whitley. I'm the lead software engineer here at AutonomouStuff. Apollo 2.0, we have cameras being added to the system. They can do stopping based on objects in front of the vehicle. They can follow at a set distance, stoplight detection.
You recognize when the cars are passing by, they're classified as cars. You recognize pedestrians, you recognize bicycles. When the light turns green, it negotiates the intersections and then moves on.
They've brought perception online faster than anyone else I've seen. You only have 2 eyes and you can only look in one direction. An autonomous vehicle is always looking in every direction at the same time.
Our goal together is to deploy fleets of vehicles to help change the way humans move from point to point. Just call the app, car comes and picks you up, it's running Apollo software, and it takes you to the next point. So it's our goal to help enable that to happen as soon as possible. Yeah, so again, completely open source automated driving stack of software that some researchers have spent their entire lives trying to create just pieces of that. That's going to change the game for automated driving and increase the rate of adoption. For the sake of time, I'm going to keep jump through a couple of these slides. It's not that easy. You just can't download this from GitHub and load it into a car and get it to drive automatically. There's quite a bit of work that it actually takes to make that happen. But the point is that it is getting much easier, and it's moving much faster than we all imagined that it would. Of course, there's lots of other things happening to make this easier. Regulations are actually now in full force moving forward. That plays a big impact on the adoption of technology. All the orange highlighted areas in this particular slide, these states have allowed platooning for automated driving trucking. The purple ones allow it in some limited fashion. The blue ones are allowing testing, but basically every state's going to allow this to happen in the next year or so. So that's all moving very, very quickly as well, which is another topic of discussion. And this slide, I know it might not make that much sense when you first look at it, but basically what it's saying is the cost of the technologies are also decreasing very, very quickly. So a LiDAR that used to cost $85,000 is now $5,000. That's the reality of today. But it needs to be more like $150. So that's what's coming in the near future. The same thing happened with radar technology. Radar technology used to be $20,000 or $30,000 for a radar that you would put on a car. Now the automotive OEMs are buying them for like $40 or $50 or maybe even less, depending on how many they put on their cars. And the same goes with high bandwidth computing, and camera technology. And as the cost drives down, of course, as the technology develops and matures, the deployment is going to go up. And we are basically at that point, or we will be very soon, within the next year, when this technology becomes affordable to deploy. The guys who can afford it now can only afford it because they're also selling their data that they get from these cars, so it's not as important to them to have a low-cost platform. That's why Google is able to deploy their vehicles, not because they're very low cost, it's because the cost doesn't really matter to them. But that's what the automotive guys are trying to figure out, how they're going to play that game. So if I were to bring this together, by the way, this is one of our facilities where we build these cars. And if I were to bring this together, and if I go back to that slide regarding the adoption of the smartphone, I think that we are just right before the iPhone was announced and related to automated driving. And I think that we're only a few years away from seeing a massive adoption and deployment of this, especially in urban cities. So that's my prediction. Just like the adoption from the horse to the Model T and the BlackBerry to the Android, automated driving today, I think that we are just a few years away from mass deployment in the cities. And that's the end of my presentation. Is your Q&A or no?
Are you okay to take a couple of questions?
Sure, yeah.
All right. Yes, please.
Describe what kind of data they're getting from the data they're selling. It's hard to understand, like driving around, images and stuff. What are they getting?
Everything. Well, just like in our smartphones today, you have GPS that tells you where you are. You have IMUs that tell you the type of activity that you're doing, at what rate. You have the cameras that see everything that you're posting in social media. You have, they can listen to your conversations and sell advertisements when you're on Facebook or whatever, right? So it's a lot like that. But instead, you are now totally captured into this automobile. And they're going to do the same thing that they do with the smartphone, but also now they can collect all this data as they're driving around, which is even more important for traffic patterns and for, I don't know, millions of other things, for updating maps, high-definition maps that also are used for automated driving, and they sell those high-definition maps to other providers that need high-definition maps that don't have fleets of vehicles driving around collecting them every day. And I'm sure that they have plenty of other ideas that I'm not thinking about, but that data is used for artificial intelligence that then they can monetize for other industry players that are developing algorithms for automated driving. Yeah, that data is like the new oil, for sure.
So related to that question, and thanks a lot, Bobby. Wonderful presentation. I learned a lot, and really interesting to see your evolution and your company's evolution in this. So more specifically, the monetization. Let's talk a little bit about social monetization. So there have been a few books recently that have come out and tried to make sense of the role of autonomous vehicles and other trends that we're seeing with respect to the concerns of this kind of conference in terms of sustainability, regulation, policy, where are we going in the future. Those are mainly written by academics. I'm wondering, from your perspective and the perspective of the other industry leaders and technologists that you interact with, how are people talking about sort of the benefits of this technology with particular respect to disrupting environmental externalities, the sort of sustainability concerns that we're focused on here?
Well, it depends on where you are in the world and the demographic of that audience. But it's really not just about automated driving. It's about the connection of everything, right? And automated driving is just kind of a piece of that. So when we get into these discussions, it's usually about what is a city going to look like in 50 years, and automated driving is just a given, and how is everything else going to be connected, and and how does everything else turn green or whatever. It's really not the, there's, most of the discussion isn't about is autonomous driving happening and how does it affect everyone, at least the discussions I'm in. That's like a given, it's going to happen. But how does it influence the rest of the adoption or the shifts in the way that humans are living?
I guess another way to frame the question is, in the discussions that you're in, where I think we're all convinced that it's going to happen right along with you or many of us, in those discussions, is there also a discussion of how to design with respect to a particular sort of set of goals that might lead us to a different sort of a more sustainable future? I mean, is that part of the discussions that you're involved in, or is that just going to be imposed by regulation and policy?
For me, I'm not as much involved in those kinds of conversations, but I know that's why these automated driving cars are focusing towards being all electric, right? That's a big player too. But for the most part, I'm the guy enabling those guys to create that vision. Yeah.
Yes, please. I'm thinking about how the summer of 2018 is the summer that the teal bikes have descended upon our town, and how that shared public space and that sharing economy is different now. And when I go visit Indianapolis or large cities, and we can rent scooters and zip around. But I will say one of the things that the bikes and the scooters don't allow me to do is be on my phone at the same time. It seems very dangerous to ride my scooter at 20 miles an hour and use my phone. Yeah. And I wonder, is this really? I mean, can I in the future, can I drive my car? Or will Amazon pick me up and take me to Chicago, and I will be purchasing groceries that will appear at the end of my trip? And how does this affect our shared space, in your opinion, public space?
Yeah, I think you just provided a couple of good examples of how mobility can change overnight. Even in a Midwest town, right, that usually doesn't adopt technology as fast as some other areas do. People ask me all the time. For one, they ask me if I trust the technology, and they ask me when it's going to come out, and they ask me, well, when can I buy an automated driving car? So I always bring up things like, the horse analogy, where everyone loved their horses, and people still have horses today. And then I bring up the analogy of how we just trust technology, and cruise control for 30 years is the stupidest technology. I mean, it would drive you into a brick wall, right, if you let it. And that's just ignorant that we allowed that to happen. But it did add some value to us. In automated driving, talking about owning an automated driving car, I don't really think that's the right business. I don't think that's going to happen. Maybe in some cases it will. But it'll just be like the scooter. You'll just call it up, and it will probably be free at some point, and it'll just take you wherever you want to go. And yes, they will monetize it somehow. You will be able to drive or buy an automated driving car that drives you down the highway like the Tesla does, or some of the other models do. But it probably doesn't make sense for you to have one that drives you completely autonomously in every situation, because if you're in a city, you'll just call up the Uber or the Google car.
There's a question.
Free for the user. What is the way that you expect it to be monetized then?
I'm not an expert on how these guys do that, but I assume it's something very similar to the way that Google and Facebook is free today. They will just get money from advertisements. Or selling the data, right? Or both.
One last one. Okay. Take this one and that one.
So thanks for the great presentation. I had a question about the research cars that you make. I understand it's modular in the software sense, that using the Apollo software, you can change algorithms and play around with it. I'm wondering how modular is it in the hardware sense? So if I have a better LiDAR or some other kind of sensor, can I just put it on and start programming on that?
I guess it depends on what you're adopting on top of it. Like the Baidu stack, for example, is very focused to a specific set of hardware requirements. In fact, they're going to come out with their own little hardware unit with Apollo 4.0. But there are plenty of other open source stacks that are more or less independent of the hardware that you connect to it. You might have to build a driver interface that's a bit different or something like that. It'll take a little bit of development, but the idea is this open source middleware is as modular as it can be.
last question.
I was wondering if you have any insights onto the sustainable practices behind a supercomputer in a bunch of personal vehicles driving all over the world, maybe in the context of Peoria.
So can you ask, what was it, can you say that again? I didn't capture what you were trying to get out of that.
So this conference is about sustainability, and we're talking about a whole bunch of hugely energy-dependent computers in everyone's personal vehicle, and I'm wondering what the impacts on Peoria might be, or Morton might be, for a huge energy sink in the personal vehicle, which is the preferred mode of transportation in urban sprawl world.
I think by the time that these are deployed in Peoria or in Morton, the energy consumption is going to be next to nothing. So the technology is adopting very, very quickly. So just a couple of years ago, if you look at what NVIDIA had to what they're announcing today, there is probably a 1000x reduction in power consumption. So the automotive market is not going to adopt something that requires massive amounts of power. So I don't think it actually is something to worry about. By the time it's driving around in Peoria, it'll just be like a smartphone inside of the car. Mm-hmm.
All right, please join me to thank Bobby again. Thank you, Bobby, for
Thank you.